Hello, Dr. Casella here, and in this video I'll be going over the flow diagram for a function we're going to create to calculate the square root. So the function will be square root, and it'll have two input arguments, a and p. This is the flow diagram for that square root function. First thing to notice is there's a loop here. Okay, and it's where it could potentially just keep going in this loop, but you notice there is an exit condition here. So the condition of the loop is specified by this block. All right, let's start here. So we have two inputs, a and p, that go into the square root function, a and p. Once a and p are passed to the square root function, then the first thing the function is going to do is it's going to set a variable x, variable name x. It's going to set it equal to the value of a, whatever was passed to the function. Then it's going to do a calculation. It's going to set a variable named y equal to the result of x, whatever it is. In this case, it's going to initially be defined as a, but then it's going to change later. X plus a over x, and then that quantity divided by 2. That's the calculation it's going to perform. After that calculation is performed, then it's going to check, is the absolute value of y minus x greater than that value p that we inserted over here? If it is, then it's going to redefine x equal to y and then recalculate y again. And again, it's going to check, is the absolute value of y, this new y, minus x, which was the old y over here, is this new value, is the absolute value of the new value of y minus x greater than p? And so what happens is y and x are going to get closer and closer to each other, because as this calculation approaches the square root value, then the square root is going to converge to whatever value it is. If I'm taking the square root of 4, I know that this has to converge to 2 because the square root of 4 is 2. So it doesn't matter how often I go through this loop, if I'm getting closer and closer to 2, eventually it's going to get really close to 2. And so this precision, when I go through that subtraction, is going to be a very small number, even smaller than this value. And so that's why I'm asking, is it greater than the precision? If it is, then keep looping through, because I want that difference to be even smaller than this small number. And when it is smaller than that small number, then I say, well, no, it's not greater. So I get out of the loop and I just return y, because y at that point will be equal to the square root of a at the precision p I'm interested in. Okay, that's all for now. Bye.